If you haven't noticed by now, there's a lot of different programming languages. You maybe even have heard of some of them: Java, Python, C++. Well, what's the deal? Why do we got so many different languages? What are they accomplishing? Well, there's a lot of reasons that we have different languages. They accomplish different goals and they get stratified in different ways. And I want to talk about one particular way that they are split up, and that is by high and low level code. Now, here's why we have high and low level code. First thing you got to understand is that computers are dumb. I know you don't think that, at least if you haven't worked with computers much, you may not think that, but they are. Just because they can do math really fast and they can calculate things, faster than you can even think about them being calculated, doesn't make them smart, because they can only do those things when they've been expressly told to. And they will do whatever they are expressly told to do without fail until something stops them. They will try to divide by zero. They will jump off a cliff if you tell them to jump off a cliff. Computers are not smart. They follow instructions. And it's our job as programmers, as coders, to make sure that our instructions are as clear and explicit as possible so that the computer does exactly what we intend for it to do. So to that end, machine language, the language that actually instructs the computer on what to do, is pretty esoteric. It looks something like this I've got on screen here. And if you're looking at it saying, well, that's not a language, that's just a bunch of numbers, yeah, you're right. This is binary language. This is machine language, and it is a set of instructions for a particular computer. I don't have the slightest idea what it does, what these instructions are telling it to do. The point is that no one really does. No one really programs in machine language because it has to be so hyper precise and so specific that it's not especially useful to program in. Now, one step up from machine language is something called assembly, and it's better, although not a lot better. I mean, you can look at this, and at least we have some letters in here, and those letters seem to maybe spell things like JMP. I don't know, is that jump? It's tough to say. Assembly is one step up from machine language, and before assembly can be interpreted by a computer, yeah, it still has to get turned into machine language. But when the need arises to write really detailed, very specific instructions to a computer, assembly is the language that is used, that is chosen. There is some marketplace out there for assembly programmers. If it's the kind of thing that interests you, I expect that you would want to find out more about it and really find out if it's something that you want to do. But it's not a huge marketplace of coders. Most coders, most programmers are working in a higher level language, the languages that we just mentioned that you've heard about: Python, PHP, Perl, Java. These high level languages look something like this. Now, they're still not English. They're not a natural language, but they are closer to a natural language. They kind of bridge the gap between the language that you and I speak, which is incredibly arbitrary, incredibly ambiguous, and not very easy for a computer to understand, and the machine language, which is totally impossible for us to understand. So in a high-level language like you see here, this is an example of C++, I believe, you see some English words in here: class, public, static, system. You may not understand what this is doing, but you would recognize those words as English words. Consequently, this code right here is a lot easier to understand than any of this code over here. It boils down to a level of what we like to call abstraction. The direct computer instructions are less abstract, while the high-level languages are more abstract. And that's really what the breakdown is here. These are the low-level languages down there, assembly and machine language, and everything else over here is a high-level language. The high-level language allows us to use some familiar words and some familiar structures of grammar, at least if you're familiar with the English language. And by using those, it's easier for us to write, but we still have a lot of structure forced upon us so that our instructions to the computer are very explicit and can be turned back into a low-level language. And that last phrase right there, turned back into, is really critical for understanding how programming languages work as well. After all, a more abstract language like C++ that I've got on screen here is useful, but it can't be understood by the computer. The computer still ultimately needs machine language. This is the instructions that the computer needs. So we've got to turn this into that somehow. And I've mentioned this before in another video, but yeah, this is done with something called a compiler. A compiler is a piece of software that runs on your computer. After you've typed up all of your source code, it takes that source code and it turns it into machine language so that the machine can actually execute the code that you've written. It can perform the instructions that you've provided inside of that source code. The analogy I like to use, and you see I've got the oven here, is sort of like baking. Source code is like your individual ingredients: your sugar, your flour, your eggs. You can't eat raw eggs, right? I mean, I guess you can, but it's gross. No one's doing that. And the computer can't eat the raw eggs either. First, they have to be, well, mixed together in something we call a linker. We're not going to talk much about that. And then after they have been linked, they go to the compiler, and the compiler bakes them. And once they have finished being baked, Now it is an edible cake. It is something that the computer can consume. We call this an executable or a binary. And this is the file that is written out in these machine language, this very esoteric, specific, but difficult to parse language. And all high-level programming languages have to go through this process before they can be executed on a computer. But all high-level programming languages are not the same. Just to break things down a little bit further here, when we get to an executable, to a binary, that's always the end goal of any program that we write. It has to be turned into an executable before the computer can consume it. It has to be machine language. There are really kind of three different types of languages in general that you're going to work with at a high level, and that is scripting languages, interpreted languages, and compiled languages. Now, what we have been talking about are compiled languages. You write the code, you run them all the way through the compiler, it outputs a binary file, a literal file on the file system, that then gets delivered to the computer where it is going to run. But there are earlier iterations that you can engage with as well. Interpreted languages, for example, stop after the linker. In interpreted language, and the primary ones of these are Java and C#, don't get compiled. They get turned into this sort of semi-par-baked, half-compiled file, often referred to as bytecode, and it's that which is delivered to the end computer where it's going to be run. Now you may be thinking to yourself, well, bytecode is not a binary. The computer can't eat that half-cooked cake, and you're absolutely correct. The final step, compiling, actually happens on the target computer. It happens on the computer that is executing the code, and it happens while it's executing it. We call it just-in-time compilation. And that's really important because what that allows us to do is write one program and compile one file from, say, C#, and then deliver it to all the different computers, and the computer itself has the code that is responsible for turning it into machine language. So my Java program can be run on both an Android phone as well as a desktop computer with Linux, even though those are dramatically different structures and they need very different binaries because ultimately they are creating the binary themselves. Finally, there's something known as scripting languages, and scripting languages are very popular. Scripting languages basically stop at the source code. You deliver the source code all the way to the end user's computer, and some interpreter on the end user's computer is responsible for executing that source code directly. Scripting is things like Perl, PowerShell. Bash is a popular scripting language in the Linux world. So scripting languages are certainly used a lot, but they do have their challenges as well. By the way, all of these are still high-level languages. The question is just how far down this process is the file created before it's delivered to the end computer or the end device where it's actually going to be executed. So that's a very brief overview of high and low-level programming languages and how they work and how they're structured. I hope this has been informative for you, and I'd like to thank you for viewing.